In this video, we're going to take a look at load balancing, and once we get into load balancing, we're going to take a look at a couple different variations in how you could affect unequal cost load balancing versus equal cost load balancing. And the idea with equal cost load balancing means if you have equal cost routes to the same destination, it's going to load balance them. Simple as that. So in a case where this might come into play, it would be right here, where 7 would want to get to this link between 8 and 9. So we're going to go to here and take a look at 7 and jump out here and do a show IP route. We'll take a look here and we'll see that the connection between 8 and 9, so trace route to 192.168.89.8, we're going to use both paths to get there. Same thing with 89. We use both paths to get there. Pretty straightforward for the most part. It's one hop away, but we use this connection between 7 and 8 and 7 and 9 to get to the same destination. So that's the idea of how you would normally get there. Now, unequal cost load balancing takes us a little bit farther. So we do a show IP EIGRP topology for 192.168.89.9/32. That's not in the table. 89.0.0/24 /27. What? Oh, 28, that's why. Okay, so there we go. So let me bring this up a little bit. So we do a show IP EIGRP topology, and for a particular route, so this is going to be this link here. What we're going to be doing is we're going to be taking a look at the routing table to see exactly how this actually all breaks down. So the idea now is relatively straightforward. So I'm going to break down the neighbor table, the topology table, the routing table, and then go from there. So it's relatively straightforward. So you have the minimum bandwidth is 100 meg. We have 200 microseconds because this is router 7, because we're dealing with classic mode EIGRP, as it says right there. We have a feasible distance of 30,720 and an advertised distance of 28,160. 28,160 is our destination, is what 8 and 9 are advertising to us to get to the next hop. And then we are adding in our reported distance, which is taking 28,160 and subtracting it from 3720. That would give us our reported distance. So total delay is 200 microseconds, reliability is 255, load is this, or MTU is that. We're good to go. So that's pretty much all there really is to it. Now, I'm load balancing over that, right? Well, what if I wanted to unequal cost load balance it? Well, I'd have to manipulate something on somewhere to make it unequal cost. So what I'm going to do is I'm going to show you guys how to manipulate this. And this is actually going to bring in quite a few different things at one time. So I'm going to go to router 8 on fast 1/1, so interface fast 1/1, and I'm going to do a do show interface fast 1/1. Currently the delay is 100 microseconds, which is 10 microseconds. So I'm going to type in a delay of 5. And do that. I'm going to do a show. Now it shows up as 50. Now if we go back to 7 and do a show that way, once it reconverges, it's only going to choose the path to actually it already did, so it's choosing the path to router 8. So do show IP route for this particular subnet. Actually, we'll just do this. It should be in the routing table. And it is. And it's learning it via router 8. We do a trace route to 192.168.89.8. It takes router 8. Do the same thing for router 8 or router 9. It goes 7 to 8, or it goes 7 to 8 to 9. So now, if we wanted a load balance or unequal cost load balance, we'd have to go in there and manipulate that. Now, if we go back up to the show EIGRP topology for this particular route, we have to make sure that remember, this is our feasible distance. If the feasible distance, if the advertised distance is less than our feasible distance, then it's a best path. So what I'm going to do is I'm going to kick in the variance on 7 to 2. That should allow us to get there. Go to global config, router EIGRP 789, and a variance of 2. Now I'm going to go down to and type in do show. Let me just do a do and pipe this guy back in. So now we're using variance, and it doesn't actually show up in here, but it will show up here. Do show IP route for this particular subnet. Notice how it shows up twice now, but notice how there's a difference between the metrics. This is the feasible distance for this path. This is the feasible distance for this path. It's better to go out this way. Now, if we do a show IP route for yeah, that is the best path. So if that is the most specific. So if we do a trace route or do trace to 192.168.89.8, it's going to use both paths. Or let's see here. I want to do a show IP route for 192.168.89.8. So it's going to use, assuming a share count of 23 to 24. If I do 89.9, it's doing the same thing, and it's going to go out router 8. So we do a trace route to 192.168.89.8. It's going to choose to go 79.9, and if it does 9, it's going to go. It should load balance, and it's not. So it's almost 1-to-1. To be honest with you, it's really, really close. But let's go to router 8. Router 8 on fast 1/0, interface fast 1/0, and do show interface fast 1/0. You're going to see that the bandwidth is 100 meg. Let's make it 80 meg. Or actually, let's make it less than that. We're using a variance of 2, so we could use 50 meg if we needed to. So we're typing the bandwidth of 50, it's in kilobits per second, so I would need to do 50K. So we do that. We're going to go back to router 7 and do a show EIGRP topology for this route. And notice how now they're pretty close still, but I don't think it's actually caught up yet. Let's do a do show IP, or I'm sorry, show IP route for 192.168.89.0. Let's do a clear IP route star, and do a trace route to 192.168.89.8. Oh, one too many 6's in there. Okay, it's going that way, and then 89.9 going directly that way. Interesting. Interesting. Okay. Well, it is showing a difference in microseconds are different. 150 microseconds there. It's seeing that the minimum bandwidth is still 100 meg. So actually, you know what? It's outgoing bandwidth. So I'm going to go to config T interface fast 1/0 and the bandwidth of 50K or 50 meg, I should say. Drop out of here and hit the up arrow. That changed it. So now it should be why is it not? It's still going. It's weird. It's not going quite the way I want it to. Show IP route. Let's see. Show IP route. It's still load balancing it. theoretically. Actually, let's do this. We do a show IP ceph internal for, or show IP ceph for 192.168.89.0 internal. It's going to send, this is how ceph is going to forward the traffic out. So we have, there's 16 hash buckets. So we have traffic is going to go this way, this one, this one, this way, this one, this way, this one, that way. And then it's going to go down. It's going to do that for the majority of it, but then the rest of the time it's going to send it out the faster link. Because we did a fast 1/0, we modified the bandwidth to be 50K, and now it's forwarding majority of it out fast 1 because it's got the better interface. So that's how the EIGRP, that's how the path selection process will work with EIGRP. So now that I've done that, I've manipulated the bandwidth, I've manipulated the delay. They've each had an effect on the path, on the forwarding capability. So even though it doesn't show that the load balancing is actually working, it actually is working. It's just that we would need to send traffic over and over and over again, and eventually it would get to where it needs to go. But I don't really have the ability to. Actually, let's do a trace route to 101.0.0.9. So it is load balancing. So we had to go find another place to go. It is load balancing though, so it does actually utilize both hops to get there. Where if I took variance off and did a router EIGRP 789 and type in no variance of 2, jump out of here and do that same thing, it's going to use 7 to 9. So it is load balancing, and it does show that. It went this way, then this way, then this way. So they are working. Now, the one thing I want to be very cognizant of is if you make the route if you manipulate something too much, you can actually cause it to fail. So, for instance, let me show you this little trick. Not really a trick; it's more of a why the K values need to match. So we're typing router EIGRP 789. We're typing metric weights, and we're going to say the type of service 0 is the only thing that's supported. K1 we're going to say is K this guy, K this one, this one, this one, and this one. So we're going to say all K values, right? We get to that guy, we're going to hit enter, and it's actually going to bounce the neighbor relationship. It's going to tell us a K value mismatch. So now we'd have to go in there and take care of that. So the metric weights have to match. There's no getting around that. So if I was just to go up here and type in no, problem would resolve itself. Now if I was to go in here and make sure that only delay is used, I'd have to type in get rid of all these guys. So this is bandwidth, so make this a 0, 0, and then this guy would be a 1, so it would only delay. And then if we were to copy, so it's going to bounce. So let's take this guy right here and move it over to 8. Actually, it's not going to make a difference. Router, EIGRP, CCNP, address family IPv4, A789, and metric weights. Actually, I think metric weights of this. So it's only using delay now. So the adjacency is up. Let's go to 9. Type exit out of here. Metric weights is just delay. We need to go to 18 and do the same thing here, and 19. So we're gonna. It's gonna take a couple seconds for that one to come up because it waits every. It goes every 30 seconds, I think, or 60 seconds. 60 seconds for EIGRP. So we can actually adjust the hello intervals too. So there it goes. So now we go back to 7, and we jump out of here and do a show IP route for 192.168.89.0. We learned it one way, and if you notice, look at the metric, 3840. We do a show IP EIGRP topology for 192.168.89.0. 89.0 89.0/28. The only thing that's being used for the calculation is the delay. So notice how low the metric values are. It's 1280. This is the feasible distance is 3840. This one here is 5120. So do we want to manipulate that to make sure it goes the right direction? Absolutely. Go up here, router EIGRP 789, and type in variance of 2. And do a /28. So it's going to allow us to load balance over both of them. So do trace to 192.168.89.8 and 89.9. It's actually not load balancing it. It's only, actually it is there. So we're going to do a trace route to trace to 101.0.0.9. We're going to load, and see in that case now it's not. It's choosing to go 7 to 9 because 7 to 9 is the better path. Or sorry, 8 to 9 is the better path. So that's how you could do that. So that's the general idea of how that would work. The other piece that I'm going to show you guys is traffic engineering. And there's a couple ways you can manipulate EIGRP to do this. You can use, for traffic engineering, you can manipulate the AD. And you have two different ways you can do this. And the AD is going to determine which protocol wins. So for instance, if you were to go to EIGRP's distances by default are 90 for internal routes and 170 for externally learned routes. So what you can do is you can go out there and actually set up use the distance command. So let's say for instance you're learning routes via BGP and eBGP, which is an AD of 20, and you want to prefer all routes via EIGRP. Well, what you'd have to do is you'd have to go to to BGP and type in that it's going to, the distance for BGP is going to be anything worse than 171 or worse, and then the router ID you want to learn it from. So the idea behind it is if you want to manipulate the traffic which way it's going to go based on ID, you can tell it, you can specifically tell it the AD that it's going to be. So it's going to be worse. It's going to prefer EIGRP or OSPF. Or you can go in there and you could specifically state what you're going to set the AD as from a particular router ID. And the idea behind it is to manipulate how traffic is learned inbound to you. So, okay, if I want to prefer the EIGRP routes, I'm going to make BGP look less preferred than EIGRP. So by manipulating the administrative distance, you can make BGP less preferable over EIGRP. So same thing with OSPF. If you want to make OSPF more preferred than EIGRP internal, you have to set OSPF's AD to be better than EIGRP. The idea is whatever protocol you want to prefer, you have to make that protocol's distance better than the current protocol being used. So if you need to manipulate EIGRP to look better than BGP, you need to make sure that either EIGRP's distance for internal and external traffic is better than eBGP's 20, so 15, 16, 17, or something like that, or bring BGP higher than EIGRP, like 171 or greater. And then if you have, or if you want to prefer OSPF over EIGRP, you'd have to go in there and manipulate OSPF down lower than EIGRP. So an 89, an 88, an 80, and whatever protocol wins based off of its administrative distance configuration will be the protocol that's used. So that's the general idea of how that would work. Another one is going to be a default routing. So if you want to originate a default route into EIGRP, there is no way to go in there and just type in what do you call it? There is. I'm sorry. You have let me think here. You can redistribute a static, so you can do a redistribute static. You can static default route to interface, the network command. So you can do network 000 underneath the underneath the process. So you can go to 7, for instance, and we're on 7. We can type in network of 0.0.0.0 and hit enter, and then 8 should do show IP route, and as soon as it reconfigures or gets the update, it should trigger. And the idea behind that is it'll learn a default route, and it might take a second for that to kick in. You can do that. And I'm not sure if it actually needs to be 0.0.0.255, or is it? Not sure if it needs to be like that or not. Let's just double check that. Clear IP. Do clear IP route star. Yeah, it's not coming in. You can go in here and do a redistribute static from another protocol. You can summarize. Oh, wait a minute. Static default route to an interface, and so that's the problem. So on 7, we'd have to. I think this one would work just fine. Exit out here and type in IP route 0.0.0.0 0.0.0.0 towards. Let me minimize this real quick. Towards 67.0.0.1, and now if we go to 8, there should be a static route advertised because we have a default route kicked in now. And actually, give me on 7. I bet you do show run pipe section EIGRP. I bet you by typing the no network command in it pull it out. No, yeah, it did. So I'm going to type in router EIGRP 789 network of 0.0.0.0. Go to 8, hit the up arrow, and it should come in. I don't know why it's not propagating. That's really weird. Yeah, it should be pulling it in, and I don't know why it's not. You could do a summary too if you'd like. And that's pretty much the bulk of them. I mean, I don't recommend you use the default network command, but it's that one's the more. You can receive a default route in if you want to, but the most common way I've seen it done is to do a summary route or redistribute static. So, like for instance, we go back to 7 here, and we type in instead of the network command, we and 8 it should be. I don't know why it's not learning it. Is it learning it on 9? Let's go to 9 and do a do show IP route. And he's not learning it either. Let's go to 7 and type in redistribute static and go to 8, and that should learn it. There it goes. See, now it's redistributing. It's learning the static route now. I don't know why I wasn't doing it to read the network command. But that's pretty much the bulk of what you can do for that. We're going to get into some. There's a question with inbound with route filtering. Is there a specific way you can manipulate traffic out a particular interface without modifying the bandwidth or the delay? Yes, there is. The way to manipulate that would be use an offset list, where if you wanted to prefer traffic out a particular interface, you'd have to make the other guy look really, really bad. So since we're under edge assembly mode, if you went to and you typed in offset list, offset, you might have to go under AF interface fast 1/0, and offset list, or no, I bet you it's under topology base, offset list, and then we'll say 0, and then outgoing towards, and we're going to say, we're going to give it some really high, we're going to go 999, some really ridiculously high metric, and then we're going to say, and this is on fast 1/0, yeah, fast Ethernet 1/0, and do show run pipe section EIGRP. And if we go to the diagram, that was out this way. So now we're offset list outbound, so it resynchronized. So with 8, so now if we go to 7, we type in do show IP route to 192.168.89.0. We're only going to choose the path towards router fast 1/1. But if we did show IP EIGRP topology /28, you'll see that the metric is really high this way, so it's not going to choose that way. So it's going to choose to go this way. So we do a do trace to 192.168.89.8. It's going to choose to go router 9, regardless of which direction I try to push it. Because if I'm sending out a really bad metric towards router on router 8 towards 7, so it's not going to want to take that route. So yes, you can do that, and that's the most common way to handle that. And so that's pretty much. I'm trying to filter in stuff as I'm going along here. What else I can show you guys? Because I'm beyond what I've shown you. There's not a lot left to go over. Router ID. When you deal with the router ID, you specifically tell it EIGRP router ID, and you specifically tell the IP address. So in this case, 10.255.7.7, and hit enter. Now, if any routes come in with this a route, and if we go to router 8 and we type, or actually let's do this since we're here. Let's do 8.8. Okay. Now, what's going to end up happening is if we type in do clear IP EIGRP neighbors, it's going to bounce the neighbors and manually cleared, so it's going to form the adjacency with both of them, and it's up. But if we type in do show IP route, I believe it's on 8. It should not install any routes because there's do show IP route. Oh, so you see 8 doesn't have the external in there. So if we go back to 7, 7's advertising the loopback. He's advertising it in. So if we go to 9 and we type in 9, we go to do show IP route. I have the external route in here, but because router 8 is receiving an external route from 7, he's not going to install it until we go to router 7 and we type in EIGRP router ID is 7.7. That'll resync. Actually, let me see if that'll take effect right away or not. Okay, there it goes. Because it sees it, so there it goes. It resynchronized. So that goes to show you how that would work. So that's pretty much everything I can think of. Let's make sure that we've covered everything here. So I've talked about load balancing, metrics. So yeah, I think I just knocked these two sections out here. What I'm going to do is I'm going to cover EIGRP redistributions in another video. Let me just run through this guy real quick. Let me pause the video and make sure I've covered everything that I need to. Okay, there's a couple minor details that I have left to cover. One of which is EIGRP timers. So we're going to go to exit out of here and type in AF interface fast 2/0, fast 1/0, fast 1/0. Type in timers, or the hello interval. The hello interval is manipulable, is configurable, and they do not have to match. So we can go in here and we can say 1 here, and that would be the hello interval, and the hold down timer is going to be, we'll say, is 2. Now, if you manipulate these incorrectly, so in order for this to work, if you have the hold down timer lower than the hello interval, the hold down timer is going to expire before the EIGRP hello comes in. So if you set the hello interval to 5 and you set the hold down timer to 2, then the router is going to bounce. Now I'll actually demonstrate that here. We'll say hold down timer is 2 and the hello interval is 3. That's going to bounce our neighbor. See, it took it down, and it's going to continue to bounce because of the fact that your hello interval is timing out before your adjacency has the chance to come in. So if we set the hold down timer to be 10, that'll fix that problem. That's the hold down timer, and actually that should fix it. Yeah, it hasn't bounced since then. So that would be how you would manipulate that. By default, it's a 5-second hello and a 15-second hold. So that we have that. And then the other one, I just saw it too, was there was a question asked, how do you manipulate traffic filtering other than with the offset list? That's actually a great question, and the way you would do that is, for instance, we'll go to router 9, and I'm going to prevent router 9's loopback from being advertised to router 7, or outbound towards towards that route. So what I'm going to do is I'm going to exit out of here and exit out of here. I'm going to type in IP prefix list, and I'm going to type in 10.255 or IP prefix list, and let's do this. We're going to type in loopback, and we're going to say deny 10.255.9.9/32, and we're going to do a permit 0.0.0.0/0 LE32, which is everything else. So do show IP prefix list, and you'll see that we have the sequence 5 comes in, and then anything else gets permitted. So we're going to go to router, EIGRP, CCNP, address family IPv4, autonomous system 789. We're going to type in topology base, and we're going to say distribute list, prefix list, loopback, and we're going to say out, which means filter outgoing service updates. So now we're going to go over to 7 and type in do show IP route, and we do a clear IP, or do clear, and actually that's what I was looking for right there. Do a show IP route, and now 9's loopback is gone. And that's gone from everybody. Do show IP route. Okay. Now that can be bad because of how things can get set up. So I don't have 9's loopback in there anymore. Now, let's say for instance you can't remove the prefix list. So we go to 9. We can't remove the prefix list. So we type in do show run pipe section EIGRP. Let's say we can't remove the distribute list, or we can't remove the prefix list. So how can we manipulate that to actually make it go back through? We want to re-advertise that. Well, we know there's a prefix list with the loopback. What we can actually do is we can go into the prefix list, type in IP prefix list loopback, and we can say, how do we do that? We can do a go to the beginning of the line, no IP prefix list, go to the end of the line. We can do 5, sequence number 5, sequence 5, deny 10.255.9.9/32. And then what we can do now is we can hit the up arrow, and we can actually go to the beginning of the line, pull that no out, go to the end of the line, and just pull that, and take that a permit. Notice how it changed now. So we took that out, so it's going to actually advertise it. But if we were to leave it as such, we would actually get our task, or the ticket wrong because we removed the prefix list manipulation. So you want to actually permit it. So it's going to resync here in a second. One moment here. And there it goes, it resynced. And then we go to 7, we hit the up arrow, and there it's being advertised. So that's what we're looking for. Everything looks good. We're in good shape with that. That's how you would manipulate our traffic filter with EIGRP. That's just one way. We'll get into EIGRP over DMVPN, redistribution, and other corner case stuff later on. They'll be specific per the They'll be specific per the particular section of the series. So we're going to do a dedicated section for redistribution, and for DMVPN, we'll cover EIGRP over both of those. I hope this has been informative for you, and I'd like to thank you for viewing.